Hi everyone, hope you are doing great. Chapter 2 Mechanics of Material. Let's solve another interesting example in strain and stress problems. So, in this example, we do have a brass strip. This is our brass strip, which sits on a two concrete blocks like at A and B. Mhm. And there is a piece of metal with weight of 100 kg standing at the support B. The dimensions are provided on the figure like the length, the width, and also height of the brass bar. And also if the coefficient of friction is 0.06 between a strip and concrete support at B, so there is a coefficient of friction, there is a friction. We want to know what is the decrease of temperature which leads to a threshold of friction force. So if this is our geometry, first of all, we do know if the brass bar is expanding, so there is a pull out bar to the support, and if there is a decrease of temperature, it's going to shrinkage. And if we draw the free body of diagrams, you can easily see if temperature drops, there is a shrinkage over there. So if there is a shrinkage, it means there is a compression push force, like a push at the two ends of our brass bar. And if we just draw the free body diagram of the B end of the bar, there is definitely a weight of this structure, like 100 kg applied to this support and a normal force in the opposite direction. And if there is a push to the right, the threshold of friction, it's opposing this force like F sub F mu S sub N. That's the friction force, and we just want to know what is the balance between the a axial force inside the brass bar and also the threshold of friction at the very beginning of motion. So, and also E is provided, and alpha temperature coefficient is provided. E modulus of elasticity of brass bar is 105 gigapascal, 10 to 9 gigapascal, and alpha coefficient expansion for brass is uh, 20 to 10 to negative 6 per degree Celsius. So first of all, if we have free body of diagram of this part, we can create it sigma forces in y goes 0, n minus w. It just gives us no motion in vertical direction. It just gives us normal force upward. Normal force is equal to weight of this is a piece of metal stands on our brass core. And also summation of forces in x goes 0. I just put the arbitrary direction like opposite of positive x. You can put it in any direction, p minus mu sub n, but be consistent for your direction. It just gives us p is equal to f sub f x. Your force inside the brass is equal to a mu times n, which is mu times mg. N is exactly like mg in a vertical direction. So as soon as we have these two equations, by jotting down the strain uh, displacement equation from mechanics of material, that's PL over EA. Nor axial force times the length of our piece over modulus of elasticity times the cross-sectional area, and then plus alpha delta T times the length, and uh, uh, because it's fixed at both ends, there is no delta, so that should go 0, and we can easily get the only unknown of our problem, which is change in temperature. Temperature drops. So if we are looking for temperature, and it just gives us flip-flop this equation, it just gives us delta T, it's equal to P over E A alpha, and that's negative. Definitely there is a negative sign here, and we just we didn't jot it down, and we just consider it like a drop in temperature because the problem statements already told us that what is the decrease in temperature. So that's why we didn't just go with the negative sign, and we just consider that there is a drop in temperature due to geometry of the problem. So if we have all information from our problem statement, like mu is zero point 0.6, area is like 20 times 3, and that's 60 millimeter square, converted to meter square, weight of the metal piece, G in SI unit, and E, which is provided to 105 10 to 9 or gigapascal. And if we just plug in the numeric value into equation, it just gives us a drop or change in temperature, like decrease in temperature by a numeric value of almost 5 degrees ish, 4.67 degree Celsius. So that just tells us there is a this amount of drop if there is a incipient of motion like by friction force. Thank you. We'll solve more problems. See you in next videos. Thank you.